Hey, welcome back everyone to the Black Brain Trust. This is episode 166. I'm here with my co-facilitator, Lionel.
Hello, hello. How's everyone doing? How you doing today, Mike?
I'm good, brother. Yourself?
I am well.
All right. Please hit the like button as you come in and share this video if possible. Also, hit that notification bell so you get the notification when we go live, as well as there is a docket in the description beneath the video. Um, you can use that to follow along on what we're discussing. So tonight's topic is Black Tech Talk and cube-based satellites, as well as Raspberry Pis and Arduinos. So I'm going to break down all three of these aspects and put it into perspective of what we're talking about tonight. And the reason why I wanted to have this hangout, why we wanted to have this hangout, was basically to cover the space startup aspect and the components that actually goes into it, and how cheap it can actually be to actually invest into a space startup, and some of the components that's going to go into it. So if you follow along, you'll see what we're talking about. I know you have anything you want to say about space and the investments and anything
Well,
you.
as more and more companies and people invest in space and space exploration, the
Mhm.
prices of getting into it is going to come down drastically. So now that we know that, we're operating from that standpoint and we're talking about it. So by the time comes where it's at a low enough price point to get into it, we would have we would know the type of information we need. We wouldn't then start learning about it.
Mhm.
We're prepping ourselves.
Mhm. Okay. Let me share my screen so you can see what we're talking about with the first item on the docket. All right. So first item on the docket is CubeSat.org. NASA and a few other agencies developed a standard for cube-based satellites. So these tiny micro-based satellites that can be utilized for basic communications and other observation models. And they come in three factors: 1U, 2U, 3U. So what happens when 1U equals 1 unit? So one cube can be stacked on top of another or stacked on top of another, and now you have 1U, 2U, 3U in a stack. And what that does is it allows for multiple operations to take place within that stack. Interestingly enough, there is a workshop that's happening next month, April 23rd to 25th in 2019 for cube-based satellites.
Hmm.
So let me click on this 6U specification. This is the first, actually, it's the first revision was done last summer, so 2018. Let me see if I can pull this up real quick. Okay, so let me just go over the overview real quick. Started in 1999, the CubeSat project began a collaborative effort between Professor George Horde Suri at California Polytechnic State University. The purpose of the project is to provide a standard for design of pico satellites to reduce cost and development time, increase accessibility to space, and sustain frequent launches. Presently, the CubeSat standard is being used to develop pico satellites by high schools, universities, government agencies, and private companies all over the world. A 1U CubeSat is a 10 centimeter cube with a mass of up to approximately 1.5 kilograms. To view the most updated versions of the CubeSat satellite designs. Go to the cubesat.org. And the purpose of this is the primary mission of the CubeSat satellite program is to provide access to space for small payloads. The primary responsibility of the companies developing 6U designs is to ensure the safety of the CubeSat and protect the launch vehicle. Primary payload and other CubeSats during launch. CubeSat developers should play an active role in ensuring the safety and success of the CubeSat missions by implementing good engineering practice, testing, and verification of their systems. Failures of CubeSats, 6U dispensers, or interface hardware can damage the launch vehicle or a primary payload and put the entire CubeSat program in jeopardy. As part of the CubeSat community, all participants have an obligation to ensure safe operation of their systems to meet the design and minimum testing requirements outlined in this document. So what's happening with this whole entire let me jump off of this real quick. What's happening with these cube-based satellites is they have various functions that could actually be beneficial to anybody who wants to get into space development. It's kind of like I would equate the cube-based satellite to feature phones and not a smartphone, if that makes any sense. A feature phone basically has smart features that do one thing. It does one thing good at a time. It can do multiple things, but it can only do one good thing at a time. What's happening with these cube-based satellites is they can only do one good thing at a time. So maybe a cube-based satellite might cover weather. Another cube-based satellite might cover you know vegetation movement for farms and stuff like that. Or even the Arctic, icebergs breaking off and things like that. They can zero down one good task at a time from these small base satellites, and it doesn't burden the cost of operation or the total cost of ownership.
Now, there's a lot in this that in my opinion, has to be unpacked. So right now, I'll compare this to crypto mining. With crypto mining, you have these ASICs, which ASIC stands for application-specific integrated circuit. But with these cube-based satellites, they're application-specific cube satellites. So they, like you said, they do one thing, but they do it very, very well. Now, with this standard that you just read, well, parts of it that you just read, these standards are good. Now you have a set standards that you have to meet, a set criteria that you have to meet, and to build these cube-based satellites. And these, it said 10 centimeters, right?
Yes.
That's very small, which means you're not building something the size of a school bus. You're not building anything the size of a tennis court. You're building something very small, and it's affordable, which means the only thing you have to really pay for is to get your payload in space.
Mm-hmm.
So the entry in terms of building the device itself is cheap. Now, what people can do is build a device and send it to space and have other people pay them for that same information, well, for the information that it gathers for them. That's a business opportunity. Now, I can see in the future where that will make low Earth orbit very crowded with these cube-based satellites because they're only doing one thing at a time.
Well, they also have limited lifespans.
Now, with that limited lifespan, it's with these cube-based satellite, well, any satellite really, after the end of their lifespan, they have to propel themselves at a distance from Earth in order to prevent cluttering low Earth orbit, but not all do that. So in the future, you're going to have a need to clean this junk up, which means that's where black men can come in and be that business. Like we always joke the same from the sun. You know, we may joke, but we're really serious. That can be a business. Now, also in the future, may come out where um, with a lot of people doing these things, doing these cube-based satellites, a lot of businesses making devices or making other cube-based satellites that you can other components where now these cube-based satellites can do multiple things at once.
Dollar War has a question in the chat. He says, "Is the small size and weight a benefit?" Yes, it is. Um, it is not a burden on the launch vehicle, so that's what the benefit is. Is
Right.
it like is it like transistor radio versus tubes that preceded it? I don't know if you can compare it to that. Basically, the technology has become so affordable and so uh, miniaturized that you really don't need much for a satellite. So that's where this is coming from.
The
Typically,
cost of
we I know myself had covered an article before about the manufacturing of a satellite can cost millions of dollars, right? So if you're trying to get a simple application specific satellite into space, you know, a cube-based satellite actually comes. Um, the design is already open source now. So basically, what I'm saying here is that a cube-based satellite fits that niche that people have been looking for all these years. If you're a poor country like in Africa or in Latin America, and you've been trying to get you know better better understanding of your country and your agriculture and things of that nature, or even try to look at poaching for that matter, right? You can use a cube-based
mm,
satellite to monitor poaching of wildlife in your country. You know, elephants and rhinoceroses being poached for their tusks. That's where a cube-based satellite comes in.
all right. These things can really decrease the price of entry
Mhm.
for people wanting to launch satellites in space.
Dollar will ask another question. You said less cost, more launches. Not necessarily. I think most cube-based satellites costs are usually bundled into it's more evenly distributed across each launch. So you're not just getting on one rocket, one launch vehicle to push one cube satellite. If you're launching one cube satellite, you're launching many at a time. So that's what they're talking about.
And
Go ahead.
and that's what Tesla's Falcon 9
Mhm.
space Falcon 9 rockets come into place, where you have this rocket with what's what's 9 times 3 is 27 with 27 boosters. It's going to be huge. Now you can fit a lot of cube satellites in there, a lot of payload in there, so you can launch many. I don't know what to maybe hundreds of cube-based satellites at one time. And I think we went over on this show where when these cube-based satellites are launched into space, they're launched one at a time, where one is launched. I think they're launched in like 10-minute intervals, something like that,
Yeah, yeah.
so they won't crash into each other.
He said in terms of weight, can each cube be sponsored by a different company doing unique research? I don't know the specifics behind that. Usually, if you like a university or a state or something like that, because I know California has quite a few. The state of California actually has quite a few cube-based satellites that they've launched over the years. So I don't know how that works or the contractual details, but it would be interesting to figure out. Let me get to this next article. All right, this one is from scitech.org.au, so Australia. Australia's small satellite revolution. A little piece of technology is making a big splash in Australia's space industry. So what on Earth is a cube satellite? We talked about what a cube satellite was. These are mini satellites, only measure 10 centimeters side and weigh about 1.3 kilograms. They can be used for a wide range of jobs. We discussed this before. So because of their low cost and versatility, these tiny satellites are great for research. We talked about that. The Australian Space Agency, ASA, has governed the launch of CubeSats in Australia since it was set up in 2018. Only a few months after ASA's formation, Australia's Space Activities Act received a major amendment, making it easier for small companies to launch satellites in Australia. Deputy head of the ASA, Anthony Murfitt, says Australia plays an important role in the international space industry, and it all comes down to our ability to track satellites in the southern hemisphere. We've got a wonderful location in the southern hemisphere, says Anthony. There are more objects in space, and people need to access that information, which means ground stations to communicate with CubeSats. We can use imaging technology and space situational awareness to monitor what's in orbit. CubeSats on Mars. That's actually a cube satellite. It's a 6U in the picture. Most CubeSats can be found in low Earth orbit, as Lionel pointed out earlier, which is an area of 160 to 2,000 kilometers above the Earth's surface. However, some CubeSats find themselves a long way from home. NASA's InSight mission to Mars is the first time we focus on the red planet's deep interior. When InSight pulled into orbit, it brought 2 CubeSats along for the historic ride, helping to communicate back to Earth. Called Marcos, the 6-unit CubeSats measure only a few centimeters. Yet they've been communicating across the 200 million kilometer divide between the planets. The Marcos CubeSats have proven it's not the size of the satellite that counts, but how you use it. So we see Australia just launched their first space agency using Cube satellites. Again, industry, we got to focus on this. Got to focus more on this. Jump to the next one. I know there's a lot of feedback coming from you.
All right.
All right, next one is from spacedaily.com. Mitigating the loss of satellite data by using CubeSat remote sensing tech. Advanced infrared and microwave sounding systems, usually on board traditional polar orbiting satellites, provide atmospheric sound information critical for nowcasting and weather forecasting through data assimilation and numerical weather prediction models. This means weather forecasts have become increasingly dependent on satellite observation. But what if we lose one or more of these instruments? How do we mitigate data gap? Dr. June Lee, a distinguished scientist at the Cooperative Institute of Meteorological Satellite Studies, University of Wisconsin-Madison, led a study to answer these questions. These findings were recently published in Atmospheric and Oceanic Science Letters. Satellites are expensive to develop, build, and launch due to the complexity of the systems involved. We are talking about hundreds of millions to billions of US dollars, says Dr. Lee. It is impossible to quickly build another satellite to replace the faulty one if anything goes wrong in space or during launch. Lee and his team used a so-called observing system simulation experiment to study the potential of 2 types of remote sensing technologies using CubeSats: the micro-sized microwave atmospheric satellite 2, MicroMOS-2, and the CubeSat infrared atmospheric sounder, CIROS, with costs measured in millions of US dollars. far fewer than those needed to replace a traditional satellite. To mitigate the data gap of the advanced technology microwave sounder (ATMS) and the cross-track infrared sounder CRIS (CRIS) on board the SUMI MPP and the Joint Polar Satellite Systems satellites. The results show that a single CubeSat was able to provide added value in terms of the forecasting of local severe storms and more CubeSats with increasing data coverage, yielding larger additional positive impacts, indicating that CubeSats may be used to mitigate data gaps left by the loss of traditional weather satellites. The study provides a possible cost-saving approach to temporarily mitigating data gap problems. More investigations are still needed, however, on the utilization of CubeSat-based remote sensing technology for weather forecasting, concludes Lee. So that's a picture of a cube-based satellite, for those of you wondering. Again, the article points out what we've been discussing is that millions of dollars can be saved by using these sort of satellites, and you don't need a whole PhD to actually figure this out. I know you have anything to add to that?
Yeah, as more and more people get into this industry, this growing industry, a lot of information, and I'm just touching on how you said you're not going to need a PhD to figure it out. When you get into this industry, a lot of more information is going to be disseminated among people that are in it, and among people that are going to want to launch their own cube-based satellites. So they're going to go and take the initiative to learn how to do it. What are what's the criteria and so forth. So that information is just going to flow freely, which means just knowing things is going to be common knowledge. Just like when we do our shows, the more you listen to our shows and take part and read and notice articles of what we talk about, it's just going to be common knowledge. And when you talk to other people that are not that don't know this type of things, they're going to look at you like you are a rocket scientist. But it's just going to be common knowledge. So like we beat the drums. Almost next month will be a year. Hey, uh, this is on the horizon. It's coming really fast, and these are the ways you can get into it. That's really much the extent I can add right now.
All right. Dollar Will has a question in the chat. It says redundancy. You have any idea what he's talking about?
I think he's speaking about what I just spoke about, redundancy. The more you do things, the it's like muscle memory. The more ingrained it is. If you do the same thing every day.
Well, maybe wait for him to elaborate on the question. More satellites can provide redundancy. Yes.
Hmm.
Yes. So, all right. Next one is from Engadget.com. NASA's latest CubeSat candidates include a solar sail test. NASA's CubeSat launch initiative is still going strong 9 years after it was first launched. In fact, the agency has just revealed the 16 small satellite projects hitching a ride onto bigger missions from 2020 to 2022. The selected CubeSats, which include ones designed to deploy antenna and another that's meant to test solar cells, come from various educational institutes and research organizations from 10 different states. The 16 chosen projects are Beaver Cube from Massachusetts Institute of Technology, Star Planet Activity Research CubeSat from Arizona State University. These are very interesting projects. I'm not going to read all of them off because this is interesting. let me read the first couple because to give some context to this. The Star Planet Activity Research CubeSat, it will monitor the solar flares and activities of red dwarfs to assess the habitability of their planets. That's really interesting. Beaver Cube from Massachusetts Institute of Technology, MIT, it was designed so that high school students can learn to design CubeSats and study the Earth's climate by measuring cloud properties as well as monitoring the temperature and color of the ocean. Again, you don't need a PhD, right? These are high school students doing this. Signals of Opportunity P-band investigation, Snoopy from Purdue University. It will measure snow and soil moisture for food security and water resources management. These are really good projects. Again, I would actually read these not so much with a grain of salt, but as a launch pad to understanding what Cube satellites are capable of being utilized for from various organizations and people of what their agenda is. So
Yeah, a range of things, and like we mentioned earlier, these things are do one specific thing very, very well.
yeah, Dollar Will asks in the chat, one project per cube. Yes. All right, next one is from room.eu.com. International collaboration spawns scalable CubeSat EO payloads. This is a let me see, that's a 1, 2. That's a 2U stack. ISIS was founded in 2006 to provide full spectrum of CubeSat missions from design to launch service, including standalone subsystems sold through its web shop known as the CubeSat Shop. SAC was founded in 2009 as a vendor-independent satellite program systems consulting and engineering bureau. An initial collaboration was agreed with the involvement of both companies' technical teams on the ISS or ISIS. Discussions about an EO payload collaboration started in February 2016 and led SAC to specify and develop the Gecko camera that was eventually flown on the InSight 1 satellite as part of the European QB50 program. Successful technical collaboration between ISIS and SAC has been driven by an open exchange of data with bilateral review of interfaces, including CAD models, thermal models, ICDs, interface control document, and software drivers. The two companies have also exchanged development hardware to support R&D processes. Again, everybody sees the value of this, of getting involved in this. The actual Cube satellite actually has a small camera at the bottom, which is what they're referring to.
Yeah, and as time right now, everything is cheap. Well, yeah, it's cheaper to get into it, and as time goes on, like we mentioned earlier, these things will be able to do multiple things at once, and it'll come as time, like I said, time goes on. And now with these cube-based satellites, at a certain point, you're able to not only monitor weather, not only monitor poaching, but not one. So you already do one thing, but two or three other things at the same time. Then now they'll be really possible for companies and people and groups of people to launch these things in space because they can do multiple things at once. So this, I, yeah, uh, I don't know if people realize the scope of this, but it's there.
Mhm. All right, this one is from SouthsideDaily.com. ODU's CubeSat moves closer to liftoff. A team of Old Dominion University students took a giant leap toward space as they joined two other Virginia universities in delivering their CubeSats to nanoracks in Houston. The nano-sized cube satellites were successfully integrated into the company's commercially developed nanoracks. CubeSat deployer in preparation for a launch on Northrop Grumman's Antares International Space Station. The launch is scheduled for April 17th from NASA's Wallops Flight Facility. It's exciting to see that all of our hard work and all of the hurdles we had to overcome and all of the long nights in the labs has really paid off, she said. In Houston, we said goodbye to our CubeSat for the last time. The satellites are part of the Virginia CubeSat Constellation mission, a collaborative project of the Virginia Space Grant Consortium and four of its member universities, ODU, Virginia Tech, Virginia, and Hampton. Three nanosatellites, each about 4 inches cube and weighing about 3 pounds, have been developed and instrumented to obtain measurements of the properties of the Earth's atmosphere. As the orbits of the satellites decay due to atmospheric drag, satellite instruments will quantify atmospheric density. This is really interesting because of what their agenda is. I'd be interested in knowing how long it plans to stay up there.
Yeah, and excuse me, they're measuring and gathering the data on the composition of Earth's atmosphere,
Hmm.
among other things. That could be the same thing. That type of technology can be used for other planets. The closest one is Venus, which is very Earth-like, and Mars. Venus, which is pretty much very much more Earth-like than Mars. The satellites that can be sent there to observe the composition of Venus and gather more information onto how it became a hothouse, and compare those um, that information with Earth, that can unleash a lot of information or useful information for further exploration and even to help with curbing the climate change on Earth. This is a lot of information that's useful. And like we mentioned, these cube-based satellites are specific. They're going to do these things very, very well. And when they gather this information on the Earth's composition and other measurements, it's going to be very precise. And that's going to spawn a lot of information that, how would I put them? Scientists can use to do whatever with. Cause yeah, I understand it. I understand it, and we're just scratching the surface on what a lot of organizations are going to use these cube-based satellites for.
All right. This next one is from dispatch.com. Tiny satellites prove their potential on mission to Mars. I think we covered this before, but yeah, we actually did. We actually covered this before in the first article, so I won't cover it again. All right, this one is from NASA.gov. 10 things CubeSats going farther. Sorry. Now that the Marcos, a pair of briefcase-sized interplanetary CubeSats, seem to have reached their limit far beyond Mars, we're looking forward to expanding an era of small, versatile, and powerful space-based science machines. This mission was always about pushing the limits of miniaturized technology and seeing just how far it can take us, said Andy Klesch, the mission's chief engineer at JPL. We put a stake in the ground. Future CubeSats might go even further or farther. One, Marco, short for Mars Cube One, was the first interplanetary mission to use a class of mini spacecraft called CubeSats. Marcos, nicknamed Eve and Wally after characters from a Pixar film, serve as communications relays during InSight's November 2018 Mars landing, beaming back data at each stage of its descent to the Martian surface in near real time, along with InSight's first image. Wally sent back stunning images of Mars as well, while Eve performed some simple radio science. All of this was achieved with experimental technology that cost a fraction of what most space missions do. $18.5 million provided by NASA's Jet Propulsion Laboratory in Pasadena, California, which built the CubeSats. Wally was last heard from on December 29th, Eve on January 4th. Based on trajectory calculations, Wally is currently more than 1 million miles past Mars. Eve is farther at almost 2 million miles past Mars. I wonder who this black girl is. Two, what are CubeSats? Were pioneered by California Polytechnic State University in 1999 and quickly became popular tools for students seeking to learn all aspects of spacecraft design and developments. I won't go anything more into this, but okay. So measuring up, the size of the cost of a spacecraft vary depending on the application. Some are the size of a pint of ice cream, while others, like the Hubble Space Telescope, are as big as a school bus. Small spacecraft generally have a mass less than 400 pounds and are about the size of a large kitchen fridge. CubeSats are a class of nanosatellites that use standard size and form factor. The standard CubeSat size uses 1 unit or 1U, measuring 10 by 10 by 10 centimeters or 4 by 4 by 4 inches. Not unlike a CubeSat, NASA's first spacecraft, the Explorer 1, was a small, rudimentary machine. It was launched in 1958 and made the first discovery in outer space, the Van Allen radiation belts that surrounded Earth. It was the birth of the U.S. space program. In 1997, the mini rover named Sojourner rolled onto Mars, a trial run for more advanced rovers such as NASA's Spirit, Opportunity, and Curiosity. Innovation often begins with the Pathfinder technology, said Jacob Van Zyl, director of the Solar System Exploration Directorate at NASA's Jet Propulsion Laboratory. Once engineers prove something can be done, science mission follows. When it comes to innovation, Marco is the same class as Explorer 1 and Sojourner, Van Zyl said. Five, testing in space. NASA is continually developing new technologies that are smaller than ever before, components that could improve our measurements on board data processing systems that streamline data uh, retrievals, or new method for gathering observations. Each new technology is thoroughly tested in a lab. sometimes on aircraft or even at remote sites across the world. But at, but the space environment is different than Earth. To know how something is going to operate in space, testing in space is the best option. At work in Earth orbit, RainCube, a satellite no bigger than a suitcase, is a prototype for a possible fleet of similar CubeSats that could one day help monitor severe storms, lead to improving the accuracy of weather forecasts, and track climate change over time. IceCube tested instruments for their ability to make space-based measurements of the small frozen crystals that make up ice clouds. Like other clouds, ice clouds are ice clouds affect Earth's energy budget by either reflecting or absorbing the sun's energy and by affecting the emission of heat from Earth into space. Thus, ice clouds are key variables in weather and climate models. First dedicated CubeSat launch. A series of new CubeSats, is now in space, conducting a variety of scientific investigations and technology demonstrations following a December 17th, 2018 launch from New Zealand. The first time CubeSats have launched for NASA on a rocket designed specifically for small payloads. Yeah, I think we covered a lot of these. The little CubeSat that could. CubeSat technology is still in infancy with mission success rates hovering near 50%. So a team of scientists and engineers set out on a quest. Their goal to build more resilient CubeSat, one that could handle the inevitable mishaps that um, bedevil any spacecraft without going kaput. They wanted a little CubeSat that could. That's interesting. Um, so many ideas are kind of flowing through my head about a CubeSat because I'm getting various costs of what it would cost for building a CubeSat. NASA was allotted $18.5 million a couple years ago. Um, I've looked at prices and they don't seem to range in the millions at all. I guess it would cost millions of dollars if you have to pay people's salaries, but I was looking at the physical product costs, so I'm kind of curious to know what the real cost is.
I am curious also because um, it can be even a single million. It got to be much lower than that because the cost of materials, understandably, you may have some material that is specific to
Mhm.
what you're building it for, but it can't be. I mean, no, I just don't see this being that much. But I am curious also. But per this article, like we said, you have these cube-based satellites that have gone way past Earth's um, atmosphere, even past Mars' atmosphere. So when they go that far, yeah, they're going to get samples and test the atmosphere of these planets and bring back more information. And all the information is going to add up because humans sent out satellites that far already. And all the information add up. And by the time we get to these planets, these asteroids, these moons, these extraterrestrial moons, we're gonna that is that it'll be that much easier to this space exploration deal to just shoot off because we'll have the information to go on. It's amazing, Um, I I don't know if I'm putting into words the brevity of it. Well, not the brevity, but the scope of this. It's wow.
Mhm. All right, this next one is from SatelliteToday.com. QTIM to launch CubeSat for cryptocurrency blockchain platform. QTIM Foundation announced a collaboration with the Space Chain Foundation to launch a standardized CubeSat, which will carry QTIM's blockchain software technology on a Raspberry Pi device. We're getting into this later. The electricity required for cryptocurrency mining or tallying cryptocurrency transactions in exchange for a small fee has increased exponentially over the years. According to Digicomis, Bitcoin mining power consumption has increased 56.2% over 4 months to hit 47.07 uh, transactional wattage per hour, costing $2.3 billion per year and consuming 0.21% of the world's electricity. And proof of work consensus algorithms, power consumption is necessary for transaction verification, which is done through proof of work mining. By launching a satellite into space with a comparatively lighter proof of stake algorithm, QTIM intends to increase its reliability with a future satellite network expansion. While most blockchain technologies use proof of work for their mining operations, QTIM uses a form of point of sale. Is it point of sale?
Proof of stake.
Yeah, it should be proof of stake, right? It says point of sale.
I don't think that it's proof of stake.
QTIM uses a form of point of sale POS for transaction verifications in the network. The satellite launch provides energy savings and cheap hardware platform. Instead of buying expensive specialized mining equipment that costs thousands of dollars to purchase, set up, and maintain, QTIM wallet holders can mine for QTIM tokens on light devices, according to the foundation. There are now more than 14,000 cryptocurrencies in the world, aside from the major cryptocurrencies such as Bitcoin, Ethereum, and Ripple. However, these cryptocurrencies are costly to maintain, which increases the barrier for widespread industrial adoption. QTIM stated. With the satellite launch, QTIM hopes to lower the cost of industrial usage, which would set the stage for mass adoption of its blockchain and also future application advantages. You're a blockchain developer, Lionel, a blockchain enthusiast. What does this mean to you? I have my thoughts.
Well, QTIM runs on ERC. I'm pretty sure it's ERC 2020, which means it's Ethereum. Okay, so QTIM Foundation announced a collaboration with. Okay, so with the proof of work protocol, it does take a lot of energy. Granted, yes, and I have heard of instances where satellites will be used specifically for proof of work because of the coldness of air that'll cool down. Things like things of that nature. Proof of stake, it's a proof of stake protocol, so I'm not for sure why. It's interesting. I have to look more into it. The article didn't give me enough information to enough breadcrumbs, should I say, to make a meal out of. It- I have to look more into it. I'm lost for words right now as to why a proof of stake protocol would have um, doing this with satellites. Now, granted, they're doing something. Their QDM is doing something. A lot of cryptocurrencies are not have anything to do. They're just there. But I give it, I give that to them. But it's not no bread and crumbs for me to really say anything. I'm curious myself. I have to look more into this.
Mhm. My take on that is that putting the crypto using a CubeSat for cryptocurrency um, wallet management and transactions actually is pretty beneficial because if you're operating outside of U.S. boundaries or other state boundaries, you're not beholden to any of the laws that's on the ground and statutes that's on the ground. So a cube-based satellite means that there is no banking laws or any of these sort of statutes that may prohibit you from having a bank actually take precedence over you. So in the United States, Bitcoin and other cryptocurrencies are iffy with the Security Exchange Commission, the SEC. And I think what's happening is that CubeSats actually provide a relay point for cryptocurrency digital wallets. So you can have an actual you can turn a CubeSat into a node as well as a relay point, basically. And it's going to take a little bit more time to process the transaction, but it's in a different location outside of hackers, if that makes any sense. You don't have to worry about the bad guys trying to break in because it's so far away, and two, it's only connected to one area of contingency. So if I have a phone and I use that phone to connect to said application or said exchange, that exchange has two factors here. One, it's in the cloud, and two, it's pointing back to a cube-based satellite to make that verification of that transaction because it's a node, and then that satellite pushes that transaction back down to the ground to whatever exchange I'm trying to do business with.
I see. So it's more of a safety / security feature.
Yes, because it's so far away. Unless somebody plans on shooting that satellite down.
Yeah, because the article only said it's joining with this company, and then it just got into what proof of stake is and what it said proof of sale, but that meant proof of stake and what proof of work is. It really didn't give any meat and potatoes onto why they just said it. So I can understand where you're coming from because with cryptocurrency, they can be people can be hacked. So I can ride with what you just laid out right now.
Why don't you look up what QTIM is doing right now?
Well, off top
Google
of my
QTIM.
Yeah, off the top of my head, I know Qtum's around $2 and some change. So, but let me look at it right now. QTUM. And that didn't go through. QTUM.
Hey, what's going on, Complex? What's going on,
Yeah.
Dominante? What's going on, C Boogie?
So Qtum is $2.76. Let me do this.
While you look up that, I'm gonna hit the next article.
Okay.
All right, this next one is from electronicsweekly.com. Need to move your CubeSat? Add a plasma thruster. The thruster is a small arc type running at tens of amps for hundreds of microseconds. Purdue's latest contribution is not the whole thruster, but a way of initiating the arc that runs it. Briefly, breaking down the insulating vacuum so that the main arc can flourish. We have created a low energy triggering technology that uses nanosecond pulses. That allows the ignition and propulsion system to function reliably for a very long time, said Purdue engineer Alexei Schercern. Specifically, we have successfully tested the ignition system for greater than 1.5 million pulses, and it remained operational and almost intact after that test. So this is interesting because what they've been able to do is take this small motor that's about the size of a chapstick or a little bit bigger and turn it into a turbo boost for cube-based satellites.
Mm. That can be used for repositioning or to go repositioning, go to other positions that or would grant it better information gathering and thrust it into once this lifespan is up, thrust into a area that it needs to go to get away from other satellites or in low Earth orbit. So
No,
wow.
this well, they think I'm thinking beyond that. It's they're talking about using it for microbursts. That means that if they were to drop this off at a different planet, they can put
Mm,
they can make their revolution around the planet multiple times using these small microbursts. Typically, a cube satellite doesn't have any acceleration at all. It actually is delivered to its location and then it sits there. It really doesn't have any acceleration.
okay, so it can say they launch one to Mars, then with the revolutions around the Earth, it can map Mars. Well, revolutions around Mars, it can map Mars multiple times. Get a well, you'll do this, you do everything in one swoop, but it can map Mars, tell you how high these mountains are, how low the depths are, so forth, so whatever water. Okay, all right. It's opened the door to a lot more information gathering with moons, planets, asteroids, and so forth. Oh, especially asteroids. We always talk about asteroid mining, so um, launch a few of these because since they're so cheap to, wow, you just opened my mind up. Since they're so cheap to make, now you have companies and people launching a few of these and governments to asteroids, figuring out on exploration mission, figuring out what asteroids will have what type of minerals or resources on them,
Hmm.
map them out, use light or infrared light to see what they contain. Wow.
Well, think about a lighter, right?
Hmm.
If you when you try to light something when you try to light a lighter by rolling the mechanism to the ignition, right? Every time that lighter sparks, when you roll your finger or you roll your thumb across it, that's what they're talking about. That small flicker in space where there's no gravity, all it needs is that small flicker to move itself.
Mm. Wow, this is good stuff.
Hmm. But you can literally do something like that with I mean, provided that you've done the research and everything else, you can do that with off the shelf hardware.
And as this information becomes more and more prevalent, there's people that's going to look at this information and say, well, like you just said, I can do this with just this. That's all what it is. And then that's going to bring the price down more and more when people use their imagination and DIY skills. I don't say DIY to do these things. Wow. Okay.
Hmm. All right, next one is from GeekWire.com. Tethers Unlimited says two-way radio for small satellites has ace first orbital test. Tethers Unlimited weathered a wave of bad news over the winter, but now some good news has bloomed. The company, headquartered in Bothell, Washington, reports that its Swift SLX S band radio has been successfully operated in orbit. The compact software defined radio provided two way communication between Harris Corp's first small satellite, known as HSat 1, and the satellite's ground operators. Tethers Unlimited said this week in a news release. HSat was launched last November by India's Polar satellite launch vehicle, with Seattle-based spaceflight handling logistical support. Swift SLX is designed to fit on CubeSat spacecraft, which can be configured to meet a wide range of mission needs, including in-flight adjustment of operating frequencies for S and L band communications. Development of the radio was supported with small business innovation research grants. sorry about that. Small base innovation research grants from the Air Force Research Laboratory and the Army Space and Missile Defense Center. Our team has worked very hard to bring the Swift radios to the level of maturity and quality necessary to meet the needs of top-tier customers such as Harris Corp. Tethers Unlimited CEO Rob Hoyt said, "The greater performance of the Swift SLX right out of the gate is a big testament to our Swift team's efforts and the collaborative support of the Harris integration team." Hoyt noted Tethers Unlimited has delivered a number of traditional radio for other flight missions. This success should give those other programs confidence that our Swift radios will perform well for their missions. So, what it sounds like to me is that these guys actually utilizing CubeSat satellites for military purposes, for radio communications. That's actually not such a bad idea if you're if you have a specific gender.
I can see I can see that because it's mm, I can't remember. I can't think of the word I'm trying to use, but we're using these things for so many things that can be used for military purposes. It's not out of the realm.
Right. All right. Let me get to the next one. All right. This one is from engineering.com. DE actually sent this in to us. 5G, the fifth generation of mobile communications, is being developed to meet a number of challenges facing existing technologies. For one, more and more people are becoming reliant on the use of these technologies. Not only that, but they are also placing more and more demands on the data they want to receive, whether streaming 4K videos, Skyping a colleague across the world, or interacting with numerous IoT devices. The challenges demand these challenges demand a novel solution, and that solution is to use millimeter wave frequencies in the range of 30 to 300 gigahertz. Satellite telecommunications suffer from many of the same problems. More and more satellites are being launched, and they want to send more and more data. Fortunately, the same solution can be applied. Use higher frequencies to communicate. To pave the way for satellites that use millimeter wave frequencies, the European Space Agency is funding a project to construct and launch a nano satellite to test the use of 75 gigahertz frequency band. The satellite, named WQ, will be constructed by Finland-based Reactor Space Lab and VTT Technical Research Center of Finland. The body of the WQ will be based on Reactor's Hello World CubeSat platform. While VTT will develop the dual frequency beacon transmitter, the signal WQ transmits will be observed at a measurement station in Gaza or in Kreis, Austria, operated by contractor Joninium Research. WQ will weigh less than 5 kilograms and is scheduled to launch sometime in 2019. It will be the first time such high frequency signal is broadcast from space to Earth. This is really interesting. I can only imagine that this must be talking about delivering internet on the cheap without actually putting up towers everywhere. They can just use a satellite. That's an interesting approach to
Mm.
Interesting
Now,
approach to dealing with this.
now I wonder, will this cover more ground, provide internet to more people, in a not a smaller, since it's small, but by it being in space or Earth atmosphere, will it provide internet to a large swath of land compared to towers? Now I know at 5G it works on shorter, um, what is it? Shorter radio frequency waves.
It can work on shorter frequency waves
Can,
on the
okay.
ground, so it can. There's various ways of implementing it. What they're looking at in this article was to point out that it can be used, whether or not it can be used at 75 gigahertz in space
Mm,
or from space, and if it can, what would the latency be for that? Because
okay.
it's the bit because they have a lot of when it comes to radio frequencies, there's a lot of bands that are fractionalized in the spectrum. So you can have like 75.1, seventy-five point
Uh,
two. It could be used for different purposes because they're not they're not running into each other. There's no collisions, radio collisions or data collisions. So if you can narrow down a specific band on a spectrum, you can actually use it for multiple purposes.
okay. I see. Now, yeah, I would be I would be interested in what the latency is, what the latency is on this, because if that's the case, if it's feasible and the latency is nil, then you can provide the whole world will be connected. Only thing you need at that point is a device to connect.
Well, if it's riding on 75 gigahertz frequency, then you would need some kind of phone or tablet or IoT device that's going to provide that sort of service for you. But
Hmm.
um, judging by um, what it costs to put something like this together, it doesn't seem like a whole lot. Because if you had to put up a tower, you have to get land rights, you have to go through the federal government, you have to do this, you have to do that, you have to talk to this person, you have to go through a lot of bureaucratic tape. Especially if you're in places like Africa where there's a lot of tribalism, you can't just throw up a tower where you feel like it.
Right. This will circumvent that. You know that that's tribalism is on land. We're talking about space and things way above you that you can't even see. It's
Hmm.
like it'll be a blanket of internet connection draped over the world, where like we just said, only thing you need is something to connect to
Hmm.
what's already there. It would be at that point ubiquitous. It'll be everywhere. It'll be omnipresent.
Hmm. And everybody will have 5G at some point. It's
Hmm.
more about we talk about Africa, but if you look at Africa in particular, you can design a phone just for the continent itself. It doesn't have
Right.
to be anything cross compatible across the world. It can actually be narrowed down for 1.4 billion people to have access to this sort of phone, and that could be the benchmark. Africans can actually lead in this market because there's so many people on the ground that they can actually drive the market the way they want it to, based on their own implementation.
Hmm. Hmm.
All right, let me get to
And this way it should be. It's because it's specific to the geographical location that it's in. It's not a one thing fits all.
mhm. All right, this one is from geekwire.com. How satellites and blockchain go together. It's been 3 months since Planetary Resources, the asteroid mining venture headquartered in Redmond, Washington, was acquired by the Consensus Blockchain Studio. And although the venture, currently known as Consensus Space, taken hasn't yet take the wraps off of its business plans, another space-centric blockchain venture just might provide some clues. Singapore-based Space Chain has been ramping up. its activity over the past year, highlighted by the launch of two nanosatellites based blockchain nodes into orbit aboard Chinese Long March rockets in February and October of 2018. Last month, Space Chain. I know there's a lot of noise coming from you. Last month, Space Chain said it ran a successful test of space to ground blockchain transactions, specifically the completion of signature verification procedure that could theoretically be used for contracts. The multi signature code wallet service, an application developed by Space Chain engineers to test the space node, shows proof of technology of being a potential cybersecurity solution for blockchain industry. Space Chain co-founder and chief technology officer Jeff Garzik said in the news release. Today, Space Chain and the Arc Mission Foundation reported that one of the digital payloads stored aboard the satellite launched in October was Arc's orbital library, containing a complete copy of Wikipedia. The orbital the orbital library on Space Chain satellite is the beginning a ring. This is poorly written, so I'm sorry if you guys think that I'm butchering this. The orbital library of Space Chain satellite is the beginning a ring of backup data orbiting around the Earth and constitutes the first extraterrestrial archive and first step in establishing more ARC libraries that will preserve human knowledge and culture. Though massive replication around the solar system, we will be able to guarantee that the ARC libraries will never be lost, even millions to billions of years in the future. The Foundation is also planning to send installments of its lunar library project for archiving on the moon surface. The first installment is being placed on Space IL's lunar lander, and the second installment will fly to the moon on Astrobotic's uh, Pergening lander as early next year. This is something we had talked about earlier in the hangout, that leveraging blockchain and using it for payments on these cube-based satellites is actually a feasible use of the satellites. You're creating these nodes that allow you to handle these transactions and step around the ISP itself, Internet Service Provider, and other bureaucratic red tape that typically would slow you down for doing business.
Yeah, yeah, yeah. This is interesting because it opens up another way. It I'm losing my words and I apologize. It opens up different avenues for innovation. It opens up different avenues of payments, different ways of doing this payments, and different ways of doing things concerning these two technology. Well, not one is technology, one is industrial. So it it's like we're at a yeah, yeah. I'll just leave it like that.
All right, next one on the docket is from NASA's Jet Propulsion Laboratory. Ever wanted to build your own Mars rover? Well, now you can. So what NASA has done with their rover is what they've done previously with the cube-based satellite. So they put up the blueprints and the ability to design your own rover that they've designed in the past for Mars and Moon missions. Let me see if I can drag this over.
So now they just open source their designs.
Correct. We designed a driving six-wheel rover with almost the same suspension system as the real real rovers on Mars, but using only commonly available components that you can easily buy online and assemble in the garage. Boom, there it is. There it is. I said this earlier. Matter of fact, I've been beating this drum since last year, since we started the Brain Trust. But this is exactly what I've been saying.
Anybody can get into it now.
Exactly.
Anybody. You can go to Ace Hardware. Oh man, imagine Radio Shack in Circuit City wasn't around, but you can go to Ace Hardware store. You can go to these circuit places online and buy the chips and wheels and ball bearings. This can be done. When imagine, you know, those people that fix their cars in their garage and it takes a long time to do it and they spend all that money to fix up a 67 Chevy, things like that. Well, you're going to be having people that are going to be in a garage on the weekend fixing, well, not fixing, building uh rovers. And now it's not going to stop there, but anybody can do it. High school, it could be a high school project, you know, a summer project to build a rover, and not only to build a rover that for the sake of you saying, "Well, we built the rover," but you can have the opportunity to send this thing to Mars. Imagine the flame that will put in young children's mind that, hey, we
Let,
built the rover, huh?
I haven't finished talking.
Oh, my bad.
Our step-by-step instructions are easy to understand, tested by the community, and should make it building a breeze, even if this is your first robot. You can build this rover for less than $2,500. The rover was built to be improved. Share your ideas, improvements with the world, and see how other groups are improving on the original design. Let me click on the design. So NASA has their own GitHub, which is very interesting. If you don't have a GitHub, you should actually register your own GitHub at github.com. Can anybody hear me?
I can hear you now.
Okay. Yeah, my connection dropped out. What was the
Okay.
last thing that you heard me
You
say?
said everybody should get a GitHub at github.com. Then you dropped out.
Okay. Yeah. So all the parts are listed here on GitHub. You can actually download the GitHub app to your phone. Open source rover project. So I don't know about you, Lionel, but this is badass. This is fucking dope.
Yeah, it looked like what's the the thing you would get young boys a rector set.
Yeah.
It looked like that.
Or Lego Mindstorm.
Yeah. Wow. Wow.
Hmm. Yeah, this is really dope. Xbox controller, Android app. Write your own Python code.
There you go. There
Now,
you go.
I didn't really get a chance to go into this, but I just want to read this one paragraph here. It says, "We chose Raspberry Pi to be the brain of this rover for its versatility, accessibility, simplicity, and the ability to add and upgrade your own modifications. Any method with which you can communicate with a Raspberry Pi, Bluetooth, Wi-Fi, USB devices can be interfaced into the controller system of the robot. So you can actually use an Xbox controller, Android app, or uh, uh, write your own in Python to the Raspberry on the right hand side that you see.
Mm.
So, and the reason why I brought this up for tonight, Raspberry Pi, is because Raspberry Pi, cube-based satellites, this open source rover project from NASA, $2,500 in right from the gate. That's what you're gonna have to spend. Now, now we're talking about the startup cost of your first space startup.
Man, this is well within the financial scope of a lot of people. Only thing that's going to push them from not doing it is choice. Or I was looking at a program where they were saying now in the future you're going to have to be a lifelong learner, and the gumption to do that is going to separate people. You know, the want to continue to learn. That's what's going to, because it's there. The information is there. The money is there. It's just if people want to do this,
Mhm.
there's no more excuses. Oh well, it's too much. No, it's not. Oh, I don't know what to do. It's there. The information is out there.
Mhm. I wish complex design was on here so we can.
Yeah, I
I,
thought he'd be on here by now. Yeah.
yeah, I'm not sure. I'm not sure where he is. Would have liked his input on this as well. 'Cause he's a tinkerer himself.
Yeah. Yeah, this is well within because this is like, taxes. You people want to take their taxes and flip it,
Mhm.
and whatever reason, it's just, hey, man, just do this. Get a couple of your buddies, and hey, we're gonna build a rover.
Mhm. All right, this next one is from Linux.com. 4 tutorials for building a rugged Raspberry Pi robot. In this series of 4 tutorials, Ben Martin provided step-by-step instructions, code, and troubleshooting tips to take you through the process of building, powering, connecting, and controlling your own Mantis robot mounted with a Raspberry Pi. This picture right here kind of shows exactly what this author is talking about, the Mantis robot. It's actually a pretty good article. I threw it in there because I thought that it would be helpful to add on to this discussion. So,
Yeah, it is helpful because the more people see who are listening to this, that there's other people getting into it. B, there's multiple ways to get into this now, and multiple ways of doing this. The more information they see, the more ways they see to get into this, the more susceptible they are to get into it, the more welcoming they'll feel to get into it, the
mhm,
more they'll want to get into it. Because it's one thing to say, hey, the prices are down. You can get into it if you always want to. Now we are showing you other people that are getting into it and what they're making, and is giving people an idea and let their imagination run.
mhm. Yeah. Next article is from Maker Faire, so makeazine.com. Just as an FYI, Maker Faire in the Bay Area, California, it's happening May 17th to May 19th, 2019. You should go get your tickets, as seen in the article. Build an autonomous RC car with Raspberry Pi. In May of 2016, the Self Racing Cars Group held an inaugural autonomous track day for full-size cars at Thunderhill Raceway Park in Northern California. Will and I both attended, but I wouldn't actually meet until a few months later. We were in, we were intrigued by the event, but we knew that full-size autonomous racing cars were not for hobbyists like ourselves. Then in November, Chris Anderson announced a hackathon for scaled-down cars, later named Do-It-Yourself Robocars, and we both showed up excitedly. The new miniseries included a league for 1/10 scale RC cars, which is a perfect scale for a low-cost car. I bought an RC car, a Raspberry Pi, and some hastily 3D printed laser cut parts. While I while I was assembling my vehicle, Will introduced himself to me and asked if he could help, thus beginning the partnership that has led to the creation of the Donkey self-driving car or self-racing car. So that's a picture of the vehicle itself that they built. Look like it has some kind of sensor to it on the front.
That's pretty cool.
Yeah, it is. And if you read, for those you want to follow, there's a breakdown of everything of how he put it together. So, and what parts he used, and so on and so forth. All right, this one is from Hack. Next one is from hackday.com. How to use LiDAR with Raspberry Pi. So basically, there's a tutorial here that shows how to take a LiDAR instrument that is used for autonomous vehicles and implement it with Raspberry Pi.
That means those RCs that from the previous article can find their way around autonomously through, let's say, a racetrack
Or even a rover on a different planet that needs to navigate itself across different areas of
terrain. Yeah.
terrain.
Mm.
So that's why I threw this in there, but it's actually a good tutorial of how to implement something with a Raspberry Pi and a LiDAR.
Yeah, this market is going to be open to a lot of people now.
Right. And then you have the next article is from raspberrypi.org. Raspberry Pi driven telescope mount. This isn't as big as the one that Lionel likes, but
Oh man. Oh boy. I'm smiling right now thinking about it.
yeah. Faced with the astronomical cost of Wi-Fi accessible telescope mount, Dane Gardner reached for an affordable star, the Pi Zero W. Even though even though you can gaze up at the night sky with your naked eye and see an assortment of stars for free, you'll need to splash some cash on a telescope to get a closer look. Dane Gardner has found a way of incorporating higher end features into a more affordable scope by making use of Wi-Fi capabilities of a Raspberry Pi Zero W. He owns a Celestron Nexstar 6SE, a computerized telescope with 6-inch aperture and fully automated mount that contains a database of 40,000 celestial objects. It automatically locates and tracks objects, making life easier for a stargazer. One thing it doesn't have, however, is Wi-Fi, nor does it allow secure shell access (SSH). The thought of having absolute control over the telescope via Linux command line was just too tempting to pass up, Dane tells us. So what this guy did was he used a Raspberry Pi to connect to his telescope wirelessly and actually control the positions that he wants to position the telescope to point to out of his 40,000 database, 40,000 celestial database.
That's pretty slick. So you know you can put your telescope on your roof or patio and go back to your computer and launch your, I forgot the name of that program. It's on tip of my tongue. I can't think about it. It's a lot about launch that program and see what's visible and send the commands to your satellite to go that way.
Mm-hmm.
pretty cool. Pretty ingenious, really.
Right.
Then you can show people on your TV, hey, this is Jupiter. Hey, this is Mars.
I actually skipped the original article that I wanted to go over. Let me pull this up again. This is from Instructables.com. Raspberry Pi for beginners. It just goes over what a Raspberry Pi is. Just in a nutshell, a Raspberry Pi is a single base computer board that has a CPU, memory, storage, and connectivity such as Wi-Fi and Bluetooth and things like that. It basically is one small computer. It's not the fastest computer at all by the long shot, but what it is a single board that's the size of a credit card used for computing, and it typically usually runs some form of Linux, or it can run Android for that matter too. I have seen one recently that actually runs Windows, which is very impressive. And typically, what a Raspberry Pi is actually capable of doing is running multiple applications at a time, in the same way a desktop computer can, but just at a slower pace. Usually, with Raspberry Pis, you kind of have an application in mind that you wanted to do, that you wanted to perform, and that application is scaled down to work with that Raspberry Pi. It's not like you're going to take, Adobe Photoshop or Fruity Loops for music production and try to run it off a Raspberry Pi. There's a variety of applications that can run on Raspberry Pi, and Raspberry Pis have a lot of support, which is why I included it into tonight's hangout, because there's so many things that can be done with a Raspberry Pi, as we talked about earlier in the hangout, that a cube-based satellite can be run off of a Raspberry Pi. NASA talked about the rover actually being run by the Raspberry Pi. So that's why I threw all this in there, because there's a variety of functions that the Raspberry Pi can actually do. I have a neighbor who has a garage that is running off a Raspberry Pi and Alexa, and it didn't cost him much to actually have an automatic garage door opener from his voice.
Mm.
It only took
That's
him a
pretty
few
cool.
days to get. Yeah, it only took him a few days to get it right. All he says is garage door open, garage door close, and it actually opens and closes as he's walking around. So he never has to touch a button or anything like that. Even when he's in his car, when he's pulling up to his house, he just says garage door open, and it automatically opens up. So
That's pretty cool. That's slick right there.
yeah, and it learns his voice. So there's a lot of things that can be done with it. Let me hit the last couple of items on the docket, and then we'll open it up for open mic. All right, this is an Arduino. So this is the Arduino site. Basically, Arduino is similar to a Raspberry Pi, but the only difference here is that an Arduino has a single-use application. So, for example, an Arduino, what separates an Arduino from a Raspberry Pi is that Raspberry Pi is for multitasking, and the Arduino is not. So, an Arduino's main purpose is to one single task at a time. So, for example, if I had a use for tweeting the weather at every sun up, right? So if I had a thermostat or a thermometer hanging outside my window, and the temperature changed at 5 o'clock in the morning every day for 7 days a week, I can have that Arduino connected to that thermometer to read it and basically broadcast or send me a text message or send me an email that says, "Hey, the temperature is such and such for today. So it only has one specific agenda. It has one task, and that's it. With a Raspberry Pi, I can do a variety of things. I can have it tweet. I can have it send me a text message. I can have it tell me or change my lights and determine um, the illumination of the lights. There's a variety of things that the Raspberry Pi can do that the Arduino cannot. But there's also a relationship between the Arduino and the Raspberry Pi, based on what they call a GPIO. And a GPIO is a general purpose input-output connector on the Raspberry Pi. And you can connect the Arduino to the Raspberry Pi for the Raspberry Pi to give the Arduino some instruction as to take the next step. And I included the LiDAR um, article on the docket because the LiDAR also becomes a part of that function. So LiDAR can actually pick up information as it scans, feeds it back into the Arduino, and then that Arduino connects back to the Raspberry Pi, and the Raspberry Pi actually processes it and interprets the next instruction for the Arduino and to the LiDAR.
That's pretty cool. That's awesome.
And the learning curve between the LiDAR, between the Arduino and the Raspberry Pi is actually very small. It's only a day or 2 days for the learning curve.
Wow.
So I threw that on the docket for that reason. Let me just pull up this next document. All right, this one is from Instructables.com. Arduino based CubeSat. So using the Arduino on a cube-based satellite. All right, so today the task is a lot easier, and the Instructable shows how you can make your own small demonstration satellite based on the CubeSat design that can even be sent aloft with a balloon. My goal is to get you started with the project so you can expand to your heart's content. Cube. I don't want to go into that. In this Instructable, though, you will build your own demonstration CubeSat from which you will learn a lot about the design of orbiting satellites and set the stage for expanding the ideas in any direction you wish. This intermediate level project lets you explore all aspects of satellite design process, from the building of the CubeSat model itself to programming the Arduino-based electronics and reading data from onboard sensors for light and temperature. I mentioned this earlier that you can use a thermostat with an Arduino to actually read the temperature and actually tweet the information out or send you a text message. So we see here that a satellite that has sensors for reading all types of information can be processed by the Arduino and then relayed back. So Arduino has that one specific task that it does correctly. And then in this article, they're basically giving you all the instructions and all the parts that they use to develop the cube-based satellite from scratch, even 3D printed. And then in this
So
picture right here is just basically going over how they printed the cube-based satellite and what parts they use. What's up?
no, I was saying, so now this is like another open source type of deal where they're giving you the information on how to go and build one step by step.
Mm-hmm.
Not only build one, but print out the project, well, print out the parts through a 3D printer.
Right, right. All right, here's the last one before we go on into open mic. All right, this one, semanticscholars.org. ArduSat, an Arduino-based CubeSat providing students with the opportunity to create their own satellite experiment and collect real-world space data. ArduSat, a short history. 4 graduate students from the International Space University with a central campus located in Strasbourg, France. Founded in 2012, the aerospace company Nanostat, Nanostatify incorporated the successful launch of the ArduSat crowdfunding campaign on Kickstarter resulted in the first design of the ArduSat payload prototype in August 2012 and a first high altitude test in October. A big day for the newborn company was November 20th, 2012, on which an agreement was signed with entrepreneur company NanoRacks LLC to coordinate a deployment of the first 2 ArduSats via the NASA and JAXA, Japan Space Agency. On August 3rd, 2013, the Japanese cargo transfer vehicle ACV-4 was launched from the Space Center in Japan to the International Space Station, carrying 2 ArduSats among 3.6 tons of science experiments. 6 days later, the ACV-4 was successfully birthed by the ISS robotic arm, Canadarm2, to the ISS. ArduSat X and ArduSat 1 were finally launched together with the Vietnamese Pico design CubeSat on November 19, 2013 from the Japanese ISS experiment module Kibo using the Poly PicoSat orbital deployer, or PPOD. This standard deployment system helps in the effort to reduce cost and development time for CubeSat developers. So basically, what they've done with Arduino is they came up with a CubeSat design that works with the Arduino for the specific task that they have in mind. They have these sensors on board that could actually be used with the Arduino-based board or the Arduino-based system. Sorry.
Okay. Hmm. I'm trying to put in words what I was going to say. Okay. So with the excuse me. So they're putting an Arduino board in a Cube-based satellite in order for it to do really specifically one specific thing, whatever it may be, whatever they choose to do.
Mm.
And they added sensors to the Arduino or to the Cube-based satellite.
Say that one more time. You broke up in the last bit.
The sensors they added, did they add it to the Arduino board or to the Cube-based satellite?
No, it's the sensors are on the satellite, but they're connected to the Arduino based board. So the Arduino board actually reads all that information.
Okay, okay. And obviously the sensors they put on the satellite is sensing whatever they wanted to sense. Okay, okay, okay. I see what you're saying.
Yeah, this is used for data gathering.
Mm-hmm.
So if the data is already being read by the sensor, the only thing that the Arduino needs to do is process it or store it.
Now, it'll be some type of storage connected to the Arduino that is going to be inside the satellite.
Yeah, it's probably like 8 megs or something like that. It's really small.
Oh, okay, okay. That ain't bad. That's really cheap.
Yeah, and I forgot to mention in the last article that the guy who designed who talked about using a balloon, a balloon with the cube-based satellite, also mentioned that you can control the balloon with the Raspberry Pi and the Arduino.
Really?
So you can have your own lift vehicle with Arduino and the Raspberry Pi for very cheap. I
I
didn't want
want.
to go into it tonight because I knew we weren't going to have a whole lot of time because too many things on the docket. But that's something I'm going to touch on next week. Is
Okay.
these these hobby-based rockets that are about 6 to 10 feet tall are actually being used with Raspberry Pis and Arduinos. Because what the Arduino can do, because it's a single-use computer, it's a single-purpose computer or single-task computer, I should say. What that can do is that can say at this certain height deploy, or detach this rocket or detach this module.
Hmm.
That's what that would do, right? And the Raspberry Pi says at when I reach that certain height, launch the Cube-based satellite and start processing the information. Then,
Okay. Okay. Now, all right. Okay. Okay. I got it. I got you. I got you. Wow. And they're using weather balloon. Well, yeah, weather balloons for this. It's pretty cool.
yeah.
That really lessens the price of sending these things up
Well, you're not going to get that high up. You're going to get up to
to the
lower
upper
a little bit.
stratosphere. Yeah.
Yeah, the stratosphere itself.
But they're still high though. You'll still see black in the curvature of the Earth,
Mhm.
and take advantage of whatever you can sense or get or data you can get from there. If you want to go to to that height, this will be a cheaper way of doing it.
Right.
Just like when in Ghana we read that article, they were sending that with that trash can up.
It was considered to be a trash can, but the image that I used for the hangout, those are the guys from Ghana who did that.
Oh, really? Wow. Okay. Oh man, I'm getting
That's why I put
excited.
that on there.
Okay.
Let me share my screen again because this is what I'm referring to right here on the Arduino page. So um, that image right there shows that this is I think it's probably like a on a smaller or medium size of a weather balloon, but basically it's being controlled by the Arduino controller.
Okay.
And it got up to the stratosphere, like you said, it's a high altitude balloon.
Hmm, that's cool.
I mean, I don't know about you, that's pretty high up.
It is. You're starting to see the curvature of the Earth and where the blue of the atmosphere give way to the black of the space. It's way above the clouds. You can see the haze of the stratosphere and everything. Yeah, you can get a lot. Just like what you pointed out earlier, where the poaching and everything, you can get you can read a lot at that height. That's more than enough. And then imagine, well, when you're that high up, you got to deal with the cold and the thin air. But once you get, since you can control the balloon, imagine, imagine attaching a Arduino, well, not a real, I would say a Raspberry Pi, because you will want to do more things too. A drone, wow.
Yeah, I got a docket for that next week. I didn't want to add all that stuff onto this doc. I just wanted to have the intro to the discussion about space startups, right?
Hmm.
All the little components that are going to be, or all the necessary components that are going to be involved in developing. Um,
Yeah, you dropped out. You there?
yeah, can you hear me?
Yeah, you said all the necessary components, then you dropped.
Yeah, the necessary components to actually getting the actual space startup off the ground.
Yeah, that's important. That's important because that'll be a big question. Well, okay, people may want to do it, or that's the next logical question. Well, what do I need? And
Right.
we're going over that.
Hmm. Yeah, and a lot of people don't really realize what this is going to cost because we talked about SpaceX, these other rocket 3D printing companies, costing billions and billions of dollars, and then we covered later on um, $20 million that the Chinese startups were able to raise to get their own startups off the ground from the Chinese government. And
Hmm.
now NASA is putting out the blueprints for everything that you need to actually get your stuff off the ground, right? The
Hmm.
CubeSat satellite, the rover, um, how much it's going to cost for you to actually get a launch vehicle or LV. You got to
Hmm.
factor all this in. Um, Obviously, you're not going to get to the moon with a space balloon. That's out of the question. But um,
It's
to
a
actually
start.
get to actually get a Cube-based satellite up, um, and it could be used for a variety of reasons. Just to test um, certain things, certain applications that you're trying to gauge what it's going to cost and
Right.
what the factors are in getting this off the ground. I don't know what a balloon even costs. But I assume that it's not millions of dollars. It's
Maybe a couple thousand at maybe hitting 100,000 at the most because what it's used for. It have to sustain itself to those heights because when you get high up, it's thin air and it's cold, but not no no
it's actually $40 for a weather balloon.
really.
Yeah, I just saw it. It just happened to pop up on my Google. But
Wow.
yeah. So this is a high altitude balloon that costs about $40.
What we waiting for? It's almost like you want to say, "Hey, you free next weekend? Let's you know order the parts real quick and get 3 day shipping and let's get started." It's wow.
So I just saw one on Amazon, and it's let me share my screen. Man.
Oh man, that look like the one that was on the Arduino website.
It yeah, it's similar. It's similar. This one can carry some weight though. So I think it carries what? Let me see, 1,200 grams.
Payload 4.6 pounds.
Yeah. That's the. I mean, what does a cube satellite weigh? What is it
If
like?
it's
1 pound or something like that?
Yeah, if it's 10 centimeters, it shouldn't, and the equipment on board
It's
shouldn't weigh that much.
it's 4.5 kilograms.
Okay.
So 4.5 kilograms, it should be about um 8 pounds or something like that.
Okay. Hmm. That's some good stuff.
And this goes up to 115,000 feet. So that's the
Yeah.
burst altitude, right?
Yeah. It shows in the picture, the last one, how I guess I'm guessing that how far. Yeah, you can see the curvature of the Earth, and you can see the blue wind, dark sky.
Hmm.
Oh man. Hey man, you free next weekend? Hey, this is awesome, man.
Hmm.
This is nice.
Yeah. So we're kind of just giving a small tally of what the entry level upfront cost is. Know that um, we know that NASA is saying 2,500 for the rover.
Hmm.
Okay, so what about the Q-based satellite? The Q-based satellite is um, give or take. So okay, so a Raspberry Pi is $50 at best, shipped to your house. Okay, the battery that you're gonna need for a Raspberry Pi is probably like another $25, $30. You're
Hmm.
talking, let's say six AA batteries, lithium ion batteries, um, rechargeable. That's probably another $20.
So we got 100 right now.
Yeah, close to 100, and then that's excluding. And then you're talking about the Wi-Fi capabilities, or there's different modules that you can buy for Raspberry Pis. Um, they usually start from $1 all the way up to about $40. So for a Wi-Fi module, I think it's like $20.
Mm.
So as you start to add on, I'm thinking $500 up front for a cube-based satellite, and then you're going to need people who can write in Python. Python is the language that you're going to have to write in because that's the kind of most common language. I mean, you can use Linux. You can probably program in C, but I think there's Raspbian operating system that they have for Raspberry Pi. So I think that's kind of similar to like a Linux-based operating system.
That's
So you're
that's
gonna go ahead.
that's two pair of Jordans,
Yeah, absolutely.
basically. You
Yeah,
know,
absolutely.
when people get their taxes, they buy the whole family Jordans.
Hmm. Hmm. And then you factor in the weather balloon is what that was $100 for that big one.
Hmm.
But I do have another docket for next week that I definitely want to focus on the launch vehicle aspect and the Raspberry Pi aspect.
Yeah, this is well doable,
Hmm.
well in the realm of being done, or possible.
Do you have anything you think would be necessary to add it, for the startup cost?
Incorporating yourself. You know, you. I will want to do this in order to grow, then be able to send things to the moon, Mars, Venus, and other areas in the solar system. Me personally, I wouldn't want this to be like a hobby. Yeah, I would prefer to grow more than a hobby. So incorporating yourself, um, then extra supplies, the whole the
Hmm.
whole thing. But up front, I agree with you. We looked up the cost, um, and when you're doing it, hey, we're gonna send this up to take measurements of this or to do this.
Hmm.
The first one, the first try or a few tries is to see, well, if it's possible. Work out the kinks. Once you work out the kinks, you see it's possible, then you really get into what you're going to do it for. What you're going to measure, what pictures you're going to take, things of that nature, and continue to build and expand and grow.
Right. I think the ability to um, leverage off-the-shelf parts like NASA was discussing is actually going to be beneficial, right? You're not talking about, you need a scientific research center to develop each and every part, and you need to know this much math, and you need to know this, you need to know that. That's not necessary right now. You need a base level education and a level of tenacity to actually and willingness to actually do this. So.
Hmm. Agreed. Agreed. And that's why that hints to what I said earlier. The information out there,
Mhm.
but the want to get the information and put it to good use. That's going to differentiate a lot of people.
Mhm. Let me see if I can pull this other thing up right now. right, let me share my screen. All right, so I'm on the Raspberry Pi's website. All right, so it says to get started, you'll need a micro SD card with noobs. That's the software in the operating system.
Mm-hmm.
And a high quality 2.5 amp micro USB power supply. So they have their own power supplies available as well. So let me click on buy it now. Whoops, can't buy it online. Let's go to Pi Shop. Okay, it's $35.
Okay, that ain't bad. Yeah.
But there's so many things that you can leverage it for, right? I mean, we talked about blockchain, we talked about cryptocurrencies. Um, Again, they talked about Python as well.
It pays for itself multiple times over.
There's going to be some kind of upfront cost. Nothing is free, right?
Mm-hmm.
So that has to be taken into consideration. So I think when it comes to not just the project, but for the space startup itself, from a project perspective, you're going to be talking about $1,000 up front.
But still, that's not bad though.
Right.
Compared to what it was at the turn of the century or even 10 years ago,
Mm-hmm.
that's still not bad at all. Not by a long shot.
Mm-hmm.
And what you're going to be doing it for, the $35, well, say $40 for shipping and handling, it's going to pay for itself. Well, depending on what's that. Well, it's going to pay for itself multiple
Mm-hmm.
times over.
Right. Right. And I think most people don't really understand what it actually takes to get this off the ground. Um, the human labor aspect is really going to be the cost factor, not so much as the parts, right? You're always going to need parts. I mean, there's no way you're gonna get this off the ground without spending some money.
Hmm.
That's a given.
But again, that goes into you having the want to do this. Once you have the want, you need certain things. Python knowledge, parts, things gonna break. Things gonna break. But the want will cover the basic things that you may need. Because the one's gonna say, well, this broke, so we got to get another part. And okay, well, this may always break, so have some parts together. Okay, we need to learn a little bit more about this Python. So me personally, I think the one is gonna automatically cover certain things.
Hmm. Hmm. What was I gonna say? That 5G is already in discussion. I mean, we covered an article earlier about that. So now you're talking about creating your own ISP out of a few $1,000s. That was unheard of, 20 years ago.
Get a weather balloon big enough, and then launch your rover into the lower stratosphere. Just for
A rover into the lower stratosphere?
just to see how to see how it'll work. Just
Wait, you mean
to
the Q-based satellite then?
yeah, something like that to see how everything works. To say, hey, we did this, we can do more. Now we need to go to these what was it, relativity rockets, and say, hey, just grow, man, just grow.
Right. Um, the microjet propulsion engines that are being developed right now will probably be available on the market, fairly soon,
Hmm.
right?
Oh man, this is exciting. And
Yeah.
and you've
Go
been
ahead.
beating the drum since last year. 1 in 3 stars are going to be space startups.
Hmm.
Complex saying you really wish you could join this hangout. Hey, we'll have another one, man. We'll have another one.
Yeah, we're gonna do it again next week, and I'm just right now just looking at the propulsion system that's connected to the Raspberry Pi. Um, yeah, thrusters. Okay. Let me
Yeah,
let me share my
you can
screen.
really build a. This is the time to build a company
Hmm.
from the ground floor. I mean, this is the time to build that company, to start it, to man, because as the time goes, you're gonna have more things come out, say, hey, NASA's looking for this, and now you're ready. Just like I said earlier, you're prepping yourself.
Hmm. This is the nano thrusters for the CubeSat satellite. It's already for sale.
30,000 pounds, maybe about what, 35,000 US dollars.
Yeah. Right. And its availability is in 4 weeks. Right. What was I gonna say? Look at these different ones. Right. At the bottom.
Mm,
So now you're talking about the supply chain aspect of the space startup and Cube-based satellites.
hmm
This site was actually mentioned in the article in the docket, CubeSat shop.
And I'm glad you mentioned supply chain aspect, because once Q satellites start to get popular, these little sites popped up and start selling these pieces. And as more and more people purchase these pieces, the price is going to come down a little bit more. And it's yeah, yeah.
Hmm.
This may not have been around 10 years ago. CubeSatShop.com may not have been around 10 years ago. You know,
Yeah, you would have to try some risky stuff on eBay with some foreign seller with no stars or nothing.
right. But now that it's CubeSat is popular, now you're getting a supply chain and ways to purchase the parts. So now everything is starting to bubble up. Everything is starting to be available for you to buy and get things off the ground.
Yeah, they actually have ready-made cube-based satellites
Mm, okay.
that start at. I should share my screen again. Let me share my screen again. Yeah, $6,000.
Oh, that's not bad.
You can't. I mean, you can't at this point say that this can't be done. So now we're talking. You're 10 grand in.
Only needs the coding now.
Well, that's where your manual labor comes in, right?
hmm
But there's already on GitHub. There's already Raspberry Pi Python based downloads available. So the code's already been written halfway. You just need to implement the instructions that you want for either the Arduino, for the Arduino controllers that are going to be connected to it.
hmm
I mean, the micro thrusters for the Cube-based satellite actually have to be activated, right? So you use something like an Arduino to actually activate the thrusters,
Yeah, yeah.
and the information still needs to be relayed back to the ground. So okay, so now the question is, well, how do you what do you need to receive all this information on the ground? You're going to need some form of satellite dish or some kind of radio antenna.
hmm
Um, I think most house antennas, residential antennas, can actually pick up the signal. So the two house antennas that two frequencies that they ride up on is UHF and VHF.
Oh,
VHF means very high frequency. UHF means ultra high frequency.
Mm-hmm.
Mm-hmm.
Yeah. Well, I know like what you said, that we're talking about what you need, and for you to have a generalized idea of what's needed to get to start this. This is it.
Mm-hmm.
This is not Star Trek with 2110. No, this is 2020
Mm-hmm.
around the corner.
Right, and what we're looking at here is basically the solar panels for the CubeSat satellite. So
Mhm.
another $1,000 or something like that that has to be tossed into it. I think next week what we're going to have to do is sit down and really tally um,
The
what it
cost.
what it costs just for the satellite itself.
Yeah.
Because if you just wanted to just throw up a piece of junk, you can do that for $100 or something like that, $200, right? Raspberry
Mhm.
Pi, some kind of some kind of Lego scripted, not Lego scripted, but you could dumpster dive and kind of take pieces of parts, from old machines and old printers and kind of bend it to what you want it to be. Yeah, you can do that,
Mhm.
but you only have one opportunity to get it up there.
Right. Right. And there's going to come a time where the reusability factor is going to come into play, and uh, once that come into play, and once that technology gets perfected and sold to these startups, then the prices are really going to come down, because now people are not going to purchase those supplies as much, or yeah, they're not gonna purchase those supplies as much. Hmm. This is
Yeah,
some good stuff.
yeah, yeah. I've been sitting on this for probably since January.
Wow. Okay. Okay.
Yeah, I've been sitting on this docket since January. Would have done it sooner if the channel did not get flagged. But now that we're talking about it, a lot of things are starting to come out now. A lot of ideas are starting to spark, and we're having a deeper conversation about it now. Because before, when we was having these conversations, it was just about space. 1 in every 3 startups is gonna be a space startup, and so everybody needs to get into space. Um, Now we're looking at the tangible aspects of it. It's like, oh, okay,
Mm-hmm. Mm-hmm.
this makes sense.
Right. We're looking at the parts. We are going over what board you need. Where to go to purchase the parts. Shop around. Yeah. We're really getting to the meat and potatoes of it.
Now you're talking about crowdfunding it.
Right. Getting a couple people to put some money in. Mm-hmm. Mm-hmm. Because like you said, like you just mentioned, at first we were saying, yeah, this is what the landscape is going to look like in the future, 1 in 3 startups, like you said. But now, today, fast forward almost a year, not even a year. Now we're talking about where to go to get your parts at,
Hmm.
and what we're going to talk about next year. So
Oh, next week we're gonna be talking about launch vehicles. So
nah, man.
so definitely something to look forward to. Launch vehicles is a bit tricky because if you haven't really dealt with rocketry and from a hobbyist perspective, it becomes a little bit more challenging. But I think with a little bit of research, that can actually that can be done.
Mm-hmm.
That could actually be done because I looked at some of the rockets that were being developed with Raspberry Pis, and they have some serious errors in the development because the G forces that are being built with these rockets from these engines are actually breaking the Raspberry Pis and other components that G,
Uh,
because when the rocket bends up, when the rocket lifts off and it bends, um, all that force is actually cracking the circuit boards.
Mm. Okay. Yeah. 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 We're gonna get into that. Yeah.
Hmm. Hmm. And then talk about, I think probably the next iteration after that will be, okay, well, what do you do for your ground-based operations? Um, what's your launch mechanism going to be? Is it going to be off the back of a pickup truck, or is it going to be designated somewhere? Um, where are you going to launch from? Because you can't just launch from the middle of Kansas or the middle of
No.
Chicago. It ain't gonna work like that. You ain't
Nah,
gonna
ain't gonna work. No
you're not,
fly zone.
well, not just no fly zone, but you're not gonna reach that highest point in the stratosphere. You got to launch at the right time, at the right day, at the what I
Right.
mean, from the right
On,
location.
on the coasts. Yeah.
Right? Or even at the highest point, right? You can be on top of a mountain. The difference between being at the top of a mountain at 3,000 feet elevated can mean the difference between how much thrust you need to get off the ground.
Good point. Very good point.
Hmm.
Yeah. Yeah. A lot of stuff go into it, but like I said earlier, when you are in it and this information is just thrown around, you pass that learning curve, it's just going to be common knowledge. And once it becomes common knowledge, you're going to think of new ways. You're going to use your imagination and think of new ways of how to do things. That's common. That's human nature.
Hmm.
You know, someone may say, "Hey, instead of I know it's very popular to do it from here, but I'm crunching numbers and this sounds much better. Save us more money." It's those things are going to come about.
Hmm.
Yeah, this is absolutely good stuff. Absolutely.
Yeah, I didn't take too many notes. If you notice that I did take really didn't matter based on the articles and some of the information that's been presented. So
Hmm.
I just categorized it in the docket the best way possible so that it flows along. But now that after reading some of these articles and some of these documents from NASA, it's helping me to understand that the running cost is going to be whatever the cost is right now. Roughly is for a Cube-based satellite is about 100,000.
Still, that's not bad.
Well, I'm saying for a more functional satellite, it's the biggest cost factor is going to be the thrusters, right? The
Hmm.
thrusters are what, 30,000 euros. So that eats up a good portion of the budget that you have set in place.
It's still not $1 million. It's coming down. It came down drastically already, and it's
Hmm.
just going to come down a little bit more to meet that price point where it's not too expensive and more people are purchasing it. That equilibrium point.
Hmm. Yeah,
Yeah.
yeah. So my closing thoughts are, come back next week for Black Tech Talk on launch vehicles and Raspberry Pis and the integration of Raspberry Pis and Arduinos. Um, and don't forget to check us out on Space and Technology on Monday for our next hangout on more space talk.
Yeah, those are mine too. Next week it's a continuation of this. We have us, like Mike said, space technology on Mondays, and also we're doing some tomorrow, right?
Yeah, we have Major League Baseball tomorrow, Black Sports Talk, Yankees, Red Sox, Dodgers,
Cabez, yeah.
and then we have Business Wealth and Power doing a presentation on cannabis for tomorrow. So right after the baseball talk.
Hmm. Hmm. Good stuff, man. Good stuff.
All right, thank
Yeah.
you all for joining us, and have a good night.
All right. See you.